Okay, this is the analysis assignment number 4 demonstration. I'm going to be using um, lecture 12 rating data. Um, I modified it a little, and this doesn't match up as well as the other data sets and the other assignments, but I'm going to do my best, and I think it'll be enough to help you if you have any questions. So the first thing we're going to do is it says run a regression with rating as the dependent variable and the other three variables as the independent variables. So just go to Analyze, Regression, Linear. So in this case, I'm going to have put rating as the dependent, and then this data set only had two variables, so I'll put the two variables in. Okay. So the first question is the overall regression significant? Now we can answer that question. We kind of have two data sets, both with this sig, and that's what we're looking at, but we want to look at this top one. This is kind of the overall. We see it's 0.000, so yes. Remember, it has to be above 0 0.5 or less than 0 0.5 to be significant. What's the p-value? It's 0.000. What percent of the variance in the rating does this regression explain? So this we want to look at the r squared, just right up here, and it's 0.920. You can write it as 0.920 or 92%. This says, is the age variable significant? Well, because we don't have age, we can just use price. And once again, now we're going to look down here at this sig level. It's 0.000. So yes, it is, and the p-value 0.000. So on to number 2. What does it ask? So now we're going to use scatter plots to plot each of these individually. So to do that, you go to Graph, Legacy Dialogs, and down here to Scatter Plot. And we'll just choose this simple scatter. So we want rating in the y-axis, and we'll do price first in the x-axis. And that'll calculate. Ooh, I forgot to open up my snipping tool. So then I just got to copy and paste this scatter plot. So you'll, for your assignment, you're going to be doing 3 of these. One for age, income, and occupation. So I'm going to do it again, but this time for brand. Now, if you remember from class, there's something different about this scatter plot because we just have straight lines. And this will happen to one of your variables as well in the assignment. So to include occupation in the regression, well, in this case it's brand because we have these zeros. What should we do? Dummy variables, and we learned this in class. And then this asks the question, who gives the highest ratings between the incomes? Now we can't do that on this data set, but I can do it here on price. So which price gets the highest ratings? It looks like the lowest price gets the highest rating. So you're basically just going to look at the scatter plot for income and find out which one has the highest ratings. And in this case, we can look down here and it's these guys up here. Um, so low price gives the highest ratings. Okay, so number 3. Now we have to construct dummy variables and then perform a regression. So this is where you can get pretty tricky. This is how you create a dummy variable. You want to go to transform and recode into different variables. Now in my data set, we're choosing brand because brand was the one that had the straight lines. And so if we look in our raw data set at brand, we can see we have a 1, 2, and 3. So there's 3 different brands that we're going to be testing. So the first one we'll just call it brand 1. Now we're gonna make so we know there's 3 values, 1, 2, 3. We just saw that in our data set. So we're gonna just start with number 1, and if there is a number 1 in the data set, we want to change it to a value of 1. This is kind of confusing. But also if it's not a 1, we want to change it to a 0, and also all other variables change it to a 0. Press continue, hit change, then hit OK. Now when we go to our data set, we can see that it's separated out some of the data from brand, and it created a binary data set here. So I basically told it anytime there's a 1, put a 1 here. So and anytime it's anything else, put a 0. So if you look across brand 1, there's the number 1. Brand 2, brand 1, 1. So we're going to do that again, but this time for the second brand. So this is where it gets tricky. Make sure that you empty this out first and then reload it back in. So now we're going to do brand 2. I'm just going to call it brand 2. And so now if the value is a 2, we want to change it to 1. We want to add that. Now my old data was in here, but all I have to really take out is the um, the old function that said turn 1 into a 1, because I was just going to reload it. You know, if it wasn't a 2, put a 0, or anything else besides a 2, put a 0. So then I hit continue, I hit change, and hit OK. I'm just going to double check my work. And yeah, so it works. So anytime there's a 2 in brand, I get a 1. So we're just going to do it for the last variable, number 3. I'm just going to double check my work. And yeah. And if you ever screw up, you can always just go in, click on the top here. If you need to redo one, just go to File, Cut, and it'll get rid of that. And then you can just go back and redo the data. So now that I created the dummy variables, I'm ready to run the regression again, but using my dummy variables. So now I want to take one of these brands out. Professor Larson will go over this in his lecture, but it's n minus 1. So you want you want all the variables in there except 1. Then you hit OK, and it'll run the regression, and let's answer our questions. So what percent of the variance does this regression explain? Remember, we get that in the R squared, so we can say 63.3%. Is the overall regression significant? Yes, it is, because it's 0.001. Oops. Now there's that, which occupation level gives the highest rating. Now, this is where it gets tricky as well. So we see brand 1 is this rating, brand 2 is this. Now, we left brand 3 out of there, and that's what this constant is. So we're looking, I believe we're looking at the B value, and we also could be looking at the T value. I'm not exactly sure. They do correlate, but as we can see, the question is, Which occupation gives the highest level? Well, in this, which brand? And it's brand 3. Do middle manage do middle managers give significantly higher ratings than lower level executives? So once again, in this case, it could be, does brand 1 give significantly higher ratings than brand 2? Well, as we can see, these numbers are bigger than, this number is bigger than 9, 20 is bigger than 9, and then it is significant. So we can say yes, brand 1 gives significantly higher ratings, and the p-value is 0.00. Do general managers give significantly lower ratings? So we could say, does brand 2 give significantly lower ratings than this constant variable? And we can say yes, it does, because it's 0.0117, which is lower than 0.05. And the p-value is 0.017. So I hope that makes sense. You kind of just go through that. It's not a perfect fit compared to your data set. And then this last question, my data set really won't fit, but I'm just going to kind of show you how to code the variables in there, because it is a little tricky. So you really got to read this. So now we're comparing incomes, and so when you go to recode the variables, so we'll just pretend it was price this time. So I'd say low price. Uh, so I'm going to go to my raw data just to see if I can. Oop, let me cancel this. So when I'm looking at price, it seems like we'll just have the cutoff. High prices, anything above 90. Medium prices between 70 and 90, and anything lower than 70 is a low price. So that's going to be important. So let's say I'm doing a high price. Just call it high. So now my range, I want it 90 through, and I'm just going to pick an outrageous number, like 800. Oops. Actually, since I need it higher than 90, I need it 90.01 through 800. Change. Okay. Now looking at our data, so now anything above 90, as you can see, has a 1. So I'm going to do it again for my medium. You're going to do something very similar to this. I believe I said my medium was between 70 and 90. My last one is my low price. So it's going to be, I'll do 0 through. I'm just going to double check my data. And yeah, I don't have any overlap. What you don't want to see is that there's a 1 in one column and a 1 in another. Then there's overlap, and you'll get bad data. You coded it bad, and you'll have to redo it. So then we just run linear regression again.